Alrighty, hello, welcome to math lesson number 3. Today's lesson is going to be super fun because we are going to go over missing numbers in all of these operations. We're going to do addition, subtraction, multiplication, and division. So a lot to go over, so I'm going to jump right in after this. Look how funny this is. I've decided to become a math teacher, but I'm only going to teach subtraction. I just want to make a difference. Get it? Get it? He wants to make a difference. That's the answer that you get when you subtract. I know. It's not funny when you have to explain a joke, so I'll just leave it at that. Okay, now, thank you for, I'm sure on purpose, missing a question from yesterday's homework, because I know you know how to do this and it was just a simple mistake, but the awesome thing about that is that I get to go over a bonus don't forget question. So yay! So let's go over this. This was actually number 19 in your homework yesterday, if you want to follow along. And there were two questions that looked very similar. They were subtraction problems like this, 3,167 minus 450 minus 78, but they had parentheses in different areas, and that actually makes a difference in subtraction, whether they're here or whether the parentheses are here. And I think you got it totally correct because you had the concept, because you got both answers different and they're supposed to be different. But let's just go over this one really quick and let's just start it. Okay, so what's the answer you get when you subtract this? Well, I'm going to start with the parentheses first, and I'm going to do just a little problem on the side. Let me use a little different color here so you can see. I'm going to do 450 minus 78 here, because that's what they want me to start with, because the parentheses are there. All right, so in order to do this, I'm going to have to do some borrowing, because over here I see that I can't subtract 8 minus 0, so I'm going to have to borrow. Let's make this a 4 and make that a 10. So now I have 10 minus 8, so I'm going to put a 2 here. Now there are two ways to look at this. On the next one, I can't do 4 minus 7 because that doesn't make sense. But I could, if I wanted to, I could do 44 minus 7 and just in my head figure out that it's 37. Or if I don't want to do it that way, if I want to borrow again, here's how we do it. I'm going to borrow from the 4, make that a 3, and turn this into a 14 right here. So now I have 14 minus 7, I get 7. And of course, on the hundreds place, 3 minus nothing is 3. So I'll write a 3. Okay, you got that totally right. So now I have 3,167 minus 372, because as you can see, that is the next step of the problem. All right, so let's go through this subtraction really quick. So I'm going to start with the ones, of course. 7 minus 2, I'm going to put a 5 here. Next, I have 6 minus 7. Uh-oh, can't do that. So I'm going to borrow this 1 from that 1, make that a 0, and make this 16. 16 minus 7 is going to be 9. And now I could do the same thing. I could think of this as 30 and do 30 minus 3 and get 27 there. But if I don't want to think that through, then I'm going to borrow from the 3. Whoops, let's see. So let's make this a 2, make that a 10. And now I have 10 minus 3, which is 7. And then I have 2 minus 0, which is 2. So I have 2,795 as my final answer. So sweet, that is the answer. All right, let's move on to today's facts practice. You have test A to go over. Here's some beautiful clouds to go to look at while you do it. Of course, you're going to pause it so you won't get to see the clouds moving, but still you can look at the pretty picture while you do it. Now, I want you to notice on the test for today, the multiplication facts, that there are some that are highlighted. So those ones, I want you to really take your time. Those are ones that you have missed in the past, and you have not missed a lot of them, but the ones you have been consistent. So I want to make sure that you know those really, really well, that they're just dripping right off your tongue. So take a little bit of extra time and do those correctly, okay? Alrighty, pause here And when you come back, we are going to go over mental math. Okay, for A of mental math, we are going to do 3 score. Remember, this is basically 3 times 20 because we're going to do 3 score. And then we're going to add 6 to that. Okay, for B, we're going to do 2.5 dozen. If you need to pause this video and take your time, then go ahead and do that. For C, what is half of 1,000? For D, we have 1,200 plus 300. For E, let's do 750 minus 500. Now you're going to have to borrow in your head here, or if you kind of visualize it like that, what I can do is just do 75 minus 50 in my head because I just think of quarters. Okay, for F, we're going to do 30 times 30. Now remember, on these you can think of it as 3 times 10 times 3 times 10. And then you'll know how to keep track of how many zeros, because if you just do the 3 times 3, you get 9. And then you have to do 10 times 10. Okay, I've given away too much. Let's go on to G. We are going to start with the number of minutes. That's why I put this Maverick here checking his watch. Start with the number of minutes in an hour. Now divide by 2. Subtract 5. Double that number. Subtract 1. Divide by 7. Okay, write down your answer. Okay, I messed up last time and forgot to have you do problem solving, so I'm not going to forget this time. In this problem solving, it goes over a theater. And look how this theater is how it's designed. So you have some seats in front, but then you have more seats kind of behind it. So it kind of has this shape, triangular shape. So in one section of a theater, there are 12 rows of seats. So I'm going to write the number 12 here. In the first, oh, no, I'm not going to write that 12. I need to read further. Okay, in the first row, there are 6 seats. In the second row, there are 9 seats. And in the third row, there are 12 seats. If the pattern continues, how many seats are in the 12th row? Ooh, so this is first row, second row, third row. So there's 4, 5, 6, 7, 8, 9, 10, 11, and it wants to know how many are in the 12th row. All right, I'm going to let you pause it right there and see if you can figure out what the answer to that is. And in the meantime, I'm going to go ahead and jump ahead to the new concept. The new concept goes over what an equation is. Now, I know you already know what that is. It's a statement with an equal sign, and the equal sign means that the two quantities on this side of the equal sign and on this side of the equal sign are actually equal. Here are 2 examples of equations. 3 plus 4 is 7, and 5 plus a equals 9. Now, of course, in the second one, this one has a variable in it, and a variable is a letter that represents a number and is often one that you have to figure out. Okay, a lot of times there are missing numbers, and the missing number is written as one of those letters, a variable, and you have to figure out what number it is that that letter is represented by. There are lots of ways that that can be done in addition. So the first way is where you have is this example. This is where you have a missing sum. So 2 plus 3 is n is the sum. Okay, but it doesn't have to be that way. You could have this filled in, and maybe you have a missing addend, and it might be 2 plus a equals 5, and then you have to figure out what the a is. You could have these the other way around. So for example, you might know this one. You might know that it's 3, but you might not know this one. So it could be b plus 3 is equal to 5. And we're going to figure out how to solve problems like that. Of course, this one's obvious because you already know in your head that b is equal to 2. But what if you don't know? What if it's not obvious? And it turns out that if you know 2 out of the 3 numbers, you can easily find the other one by subtracting. So it's easy to show when you have an easy problem like this. All you do, the way I think of it is probably the way your teacher was describing. If the equal sign is like a line or a division across that equation, you can do the same thing to both sides of an equation and not change anything, right? So for example, I might do the same thing to both sides of the equation by subtracting 3. Subtracting 3. And then I have b is equals to, and the reason I can skip all this is because 3 minus 3 is 0. So it would basically be b plus 0, but you don't have to write plus 0 because it doesn't mean anything. And then on this side of the equation, I have 5 minus 3, so I can just write 2. And this actually gives me the answer right away. B is equal to 2. And I got that because I did the same thing to both sides of the equations. And what I did is I did the inverse operation. I just got rid of the 3 that way. Okay? All right, now what if we have a really complicated problem like this, where there are a lot of numbers? And here you can see we have one variable right in the middle of all of that. Well, easy. The first thing that we do is add all the add-ins together. So 3 plus 4 is 7. 7 plus 8 is 15. So 15 plus 7, what do you get? 17, 19, 20, 21, 22. 22. Okay, so then it's 22 plus n equals 40. All right, easy peasy, right? And then I solve that just like I did the 2 plus n is 5, right? So I'm going to do the same thing to both sides of the equation. I'm going to subtract 22, and then I end up with n is equal to 40 minus 22. So let's figure this out. Well, I can't do 0 minus 2 because I need to borrow. So let's change this 4 to a 3 and make that 0 a 10. 10 minus 2 is 8. 3 minus 2 is 1. So now I have n is equal to 18, and that's the answer. And the way that you check an answer is you go back to the original problem. So if n is equal to 18, then I should be able to plug in 18 into here, 22 plus 18, and that should be 40. Or I should also be able to plug it in here to where this n is. Let's erase that. Whoops, didn't mean to erase that one. So if I plug the 18 in there and do the math there, then 3 plus 4 plus 18 plus 7 plus 8 should be equal to 40. So you can check your answer that way. But I know that that's right. Okay, now let's go over example 1. And this is on page 16 if you're following along. It says find the missing number in each equation. All right, so the first one is n plus 53 is 75. Now this one is not obvious, so I'm going to subtract 53 from both sides. Okay, what do I get? Let's see, 5 minus 3 is 2, and 7 minus 5 is 2. So n is equal to 22, and that's my answer. Bam. And the reason I can ignore this now is because 53 minus 53 is 0, so that basically just cancels out. All right, what about B? 26 plus A is equal to 61. Okay, so I'm going to subtract 26, subtract 26. Now this is going to cancel out, so I'm left with A is equal to whatever this answer is. And let's do some borrowing because I can see that I can't do 1 minus 6, right? So I'm going to have to borrow, make that a 5, make this an 11. 11 minus 6 is 5. And 10's place, 5 minus 2 is 3. So A is equal to 35. Now, I'm going to go back and check my answer. So if I do 26 plus 35, I should get 61. And turns out that checks out. So easy peasy. Let's do C. C, we have another one of these long ones. That's super fun. They think they're going to trick us, but they cannot. Okay, so there's, I could do it this way. 3 plus 4 is 7 plus n plus 7 plus 8 is 15 is equal to 40. Didn't we just do this one? I swear we just did this. 15 plus 7 is, because now I've got to simplify further because I don't have the n all by itself. My goal is to have the n all by itself to basically isolate the variable. So I still have to add 7 plus this 15 over here. Okay, what's 7 plus 15? It's 22 plus n equals 40. Now I do it the same way as the other ones. Let me get a different color so you can see it. Subtract 22 from both sides. This cancels out, so I have n is equal to the answer of 40 minus 22. Let's get a different color and do that math. So I see 0 minus 2. I can't do that. Let's borrow again. I just love borrowing. No, I don't love borrowing. It's not a good thing. All right, 10 minus 2, now I can do that, is 8, and 3 minus 2 is 1. So n is equal to 18. Now I could be like, I'm not so sure of that answer. So let's plug it in and make sure that it's right. I can plug it in. Since n is equal to that, I can plug it in anywhere there's an n, right? So I can take this 18 and put it right here into the original problem, and I should be able to figure out, is 3 plus 4 plus 18 plus 7 plus 8 40? And indeed it is. So I have checked it, and that is correct. All right, what if there are missing numbers in a subtraction problem? How do we do that? Now the inverse operation is going to be addition. So we're going to have to add to figure these out. So here in this example, we have a missing, remember what this term is called? A missing minuend. Remember that? It's called, let me write it. A missing minuend. Okay, and minus for subtraction, and it's the number that you subtract something from, so it's the bigger number usually. Okay, that's a missing minuend. Now you could know that number, and you could have something like this, 5 minus x equals 2. This is a missing subtrahend, where the x is missing. Okay, so it could be that. You could also have 5 minus 3 is equal to m, and in this situation, you have the missing difference. Remember why I became a math teacher? I just want to make a difference. Of course I want to make a difference because I want to find the answer to this subtraction problem. All right, so to find a missing minuend, we basically have to do the inverse operation, which is to add. Okay, so when we add, these are going to cancel out because negative 3 plus 3 is 0. And I'm going to be left with n is equal to 5. Right? Easy peasy. All right, of course it makes sense when you're doing a simple problem like that. Let's see if we can do an example and do it with a little bit more complicated problem. So let's do example 2. This is on the bottom of page 16. And we have p minus 24 is equal to 17. All right, sweet. The inverse operation is to add. And I want to get the p all by itself. So now I can do that. P is equal to, because that all cancels out, the answer to this problem. All right, let's start with the ones. 7 plus 4 is 11. So let's put a 1, carry a 1. We're adding this time. 2 plus 1 plus 1 is, of course, 4. The answer is 41. Now, how do we check our problem here? Well, to check our answer, we know that P is now 41. So I should be able to erase this p and plug in 41 to where that was, to the original problem. And I should be able to see, does 41 minus 24 equal 17? And turns out it does. So we got it right. Easy peasy. Let's do the next example. 32 minus x equals 14. Now, this one's a little trickier. The way that I do it, you could do it a couple ways. So the way that they explain it in the book, it says to find a subtrahend, which is what this is, then you subtract the difference, which is this, from the minuend. So you do 32 minus 14 to get this answer. Now, in my mind, I'm kind of doing algebra in my head. So I want to isolate the variable. So what I do is I take the x to the other side. So I'm going to add x here, and I'm going to add x to this side over here. And I get 32 is equal to 14 plus x. Why do I get that? I get that because this cancels out. Negative x plus x is equal to 0. And then on this side, I have 14 plus x, which is this. So now this is a problem that I know how to do, because now I can just subtract 14 from that side and subtract 14 from this side. Remember, I'm doing the same thing on both sides of the equation, and the equal sign is the equation. So as long as you do the same thing to both sides, it doesn't matter, you'll get the right answer. Right here, negative 14 minus 14 cancels out to 0. So x is going to be equal to whatever this answer is here. All right, so let's do it. Let's do 2 minus 4, which we can't. We need to borrow something. So let's start borrowing. We'll make this a 2. We'll borrow, make that a 12. So I now have 12 minus 4. So 12 minus 4 is 8. And then let's do the tens place. 2 minus 1 is 1. So I have x is equal to 18. It doesn't matter if it's written 18 is equal to x. It doesn't matter. It's the same thing. 18 is the answer. How do I check it if I'm not sure of all of that? Well, if x is equal to 18, I should be able to take this 18, plug it back into that original equation. Is 32 minus 18, what do I get? I get 14, and that is correct. That's a correct statement. So then I know that my answer is right. Okay, hopefully that wasn't too confusing for you. If you have questions about that, text me, or you know what, text me if it makes sense. Just send me a text and say, makes sense, Mom, and then I'll know where you're at in your lesson. All right, what do we do with missing numbers in multiplication? Okay, there are a couple ways that they can present a problem like this. Of course, you could have a missing product where you have a multiplication problem and you just don't know the answer to it. That's what that means. You could have a missing factor. So instead of knowing this 2, maybe we don't know the 2, and maybe we know that the answer here is 6. So 3 times 2, 3 times f, or 3f is equal to 6. Now remember, you can write that a couple ways, and the way they wrote it in this example is 3f. That is the same as 3 times f, or 3 times x, is equal to 2, except for instead of having a missing product, we have, of course, a missing factor. Okay, now the other one could be missing as well. So they could have written the problem like this. They could have r times 2 is equal to 6, and you have to solve for r. Either way, we're going to do the inverse operation of multiplication, which is division, to figure it out. So we would do the same thing to both sides of the equation, divide by 2, and that leaves us with r is equal to, and the reason I can do that is because a 2 on the top, a 2 on the bottom cancels out. You get the identity property 2 over 2 is the same as 1. So it's basically r times 1 now is equal to 3. Easy peasy. If If you're not sure of your answer, go back to the original problem. Plug in the 3 in place of that r. So if I do that, 3 times 2, I know that the answer is 6, so this makes perfect sense that it's right. All right, let's do example 3. For example 3, we have 12n is equal to 168. So of course what that means is 12 times something is equal to 168. You can read how they do it, but it's basically what I do is the same thing to both sides of the equation. I'm going to divide this by 12. I'm going to divide this by 12. Now, a 12 over 12 just makes a 1, and a 1 times n just makes an n. So n is equal to 168 divided by 12. And so now they are going to do an example of long division here. So let's do it. I'm going to move this stuff out of the way, and I'm going to do a little erasing. Okay, so just so I have room. And let's do long division. 168 divided by 12. All right, so now I'm looking, does 12 go into 1? Nope, of course not. Does 12 go into 16? Absolutely does. It goes in there 1 time. 1 times 12 is 12. Now I'm going to subtract, and I get 16 minus 12, which is 4. I'm going to bring down that 8. 12 going into 48 now. And so I have to think to myself, how many times does 12 go into 48? It goes in there 4 times. So I'm going to put a 4 up here, and then I'm going to do 4 times 12 and write the answer here. 4 times 12 is 48. So I get a remainder of 0, and so the answer is 14. Now, if I'm not sure of my answer, then I go back to the original problem, plug this in for n, and so let's check it. So the original problem was 12 times n, now I'm going to do 12 times 14, is equal to 168. Is that a true statement? If it is, then I got the answer right, and it turns out that it is, so easy peasy. Let's move on to B. If I'm going too fast, skip back, listen to it again. If I'm still going too fast, then just text me. But I think that you know this stuff already, so I'm just going to keep going. All right, this one is 7 times k is equal to 105. So I am going to do the inverse operation, which is division. Let's divide this side by 7, divide this side by 7. Now, 7 over 7 is just 1 times k, so it's just basically k. K is equal to 105 over 7. So let's do some more long division here. Sweet, gotta love that long division. All right, how many times does 7 go into 10? It goes in there 1 time. 1 times 7 is 7, subtract, I get 3, bring down that 5. Now let's see, how many times does 7 go into 35? And turns out that it goes into it 5 times, so I'm going to put that there. Now I do 5 times 7, which is 35, and I get a remainder of 0. And the answer here is 15. So then I know that k is equal to 15. And this is how I would write the answer and circle it in my homework. And if I wanted to check it, of course, then I take this 15, I plug it into where that k is. So then I figure out 7 times 15. What is that? Is it equal to 105? If I get a true statement, then I got the answer correct. Okay, easy peasy. Let's do example C. Example C is 2 times 3a is 30. Now, this one is a little tricky because there are 3 factors, and I think they're just trying to trick us because this is easier than it seems. Because basically what it is what is 2 times 3 times a? And we know from the, from which property? Commutative property? Is it commutative or associative? I think it's, you tell me. You tell me if it's commutative or associative. It doesn't matter because you can just simplify this to 6a is equal to 30. It's because it doesn't matter which one you do first. I think that's associative because you could do this first or you could do this first. And with multiplication and with addition, you'll get the same answer. So now this is an easier problem to deal with. 6 times a is equal to 30. So let's figure this out. The inverse operation is division. So I'm going to divide both sides by 6. I'm going to make that cancel out because 6 over 6 is just 1. So now I have a is equal to 30 divided by 6. And when you take 30 divided by 6, I can just do that in my head because I know that 6 times 5 is 30. Now, of course, let's check the answer. So I'm going to take this 5 and put it up here in place of that a. So let's do 2 times 3 times 5. Does that make 30? And turns out, yes, it does. So we got the answer correct. So a is equal to 5. That's the answer. I should circle. All right, let's move on because I know that you are loving this, right? So we're going to do one last concept, which is missing numbers in division. Okay, so in division, when you have missing numbers in division, you could have a missing quotient. Remember, a quotient is basically the answer you get in a division problem, so it would look like this. Now, this is the easiest one, I think, because all you have to do is divide this and you get the answer. So that's fine. Now, what if you know the quotient? So instead of having a missing quotient, we have a missing divisor. Now, divisor is the thing on the outside of the house that's wanting to come in, right? So that's this guy right here. So a missing divisor is an example like this. 24 divided by m is equal to 8. Now, when we do this, well, I'll show you how to do it in the example, but basically the inverse operation of division is multiplying. So to find a missing divisor, we're going to actually divide the dividend by the quotient. 24 divided by 8 is 3, and that's going to go there for the answer. Okay, so you could have that's how you do a missing divisor. To do a missing dividend, so a missing dividend, let's say you know everything except the dividend. Now, dividend, remember, is like the couch that is in the den, and so that's the big number that is missing. So you might have a missing dividend, and you might know that this is 3. So then you have to figure out what is the big number that you're dividing by 3 to get 8. And to figure out these problems, when you have a missing dividend, you do the inverse operation, and you are going to end up multiplying the quotient and the divisor to figure out what the dividend is. So let's do some examples so you can see this in action. All right, let's do example 4. Okay, so a divided by 3 is equal to 15. So this is an example of finding the missing dividend because we're trying to find the big number that's missing, right? And so we're going to do the inverse operation. Now, what I still like to do this thing where I do the same thing to both sides. If I multiply both sides by 3, so I'm going to put a 3 on top and this is kind of like the top of a fraction over here on this other side, because it could be 15 over 1. I don't know if it's easier for you to visualize that way, but I'm multiplying by 3 on the left, so I have to multiply by 3 on the right. And it would be on the top of the equation if I think about it that way. But that's where it goes. Okay, and And since there literally is an equation on the left-hand side over here, then the 3 goes on top. When you're multiplying by 3, it goes on top. It's like multiplying by 3 over 1. And multiplying this side by 3 over 1. You have to do the same exact thing to both sides. So when I do the same exact thing to both sides, those cancel out because 3 over 3 is just 1, of course. So then A is equal to 15 times 3. And then I can just kind of do that in my head, and I get 45. Because I did 15 times 2 is 30, and then I added another 15, and I got 45 in my head. Okay, sweet. Let's do example. Oh, he's smiling because he thinks we're done, but we're not quite done. We have one more example, and then I'll get to his cute smile, because it is kind of a sweet smile. All right. I shouldn't say sweet to someone who swears as often as he does. That's not quite the right word. But let's do B. B is 64 divided by B is equal to 4. Now, the way I do these is a little bit different than how the book does it, because I try and isolate the variable on one side, and in order to isolate the variable here, I'm going to actually multiply both sides by B. So I'm going to put a B on this side and a B on this side. And then my B's on the left are going to cancel out because I have B over B, which is always going to be equal to 1. So the only thing that I have on the left is 64, and that is equal to 4B. I don't know why I do it that way, and I don't know if it's easier for you to do it that way, but anyway, that's how I do it. So now I have a problem that I'm used to doing. And again, I'm going to do the same thing to both sides of the equation. Divide by 4, divide by 4. These 4's cancel out because they just make a 1. And I have B is equal to 64 divided by 4. Now you might be able to just do that in your head. Let's see. 64 divided by 4. No, let's do long division just to be sure. Okay, so if I do long division, let me do that with a different color. 64 divided by 4. All right, so 4 goes into 6 one time. 4 times 1 is 4. Subtract, I get 2. And I bring down that 4. How many times does 4 go into 24? 4 times 6 is 24. Okay, so if I do 6 times 4, now I get 24, subtract, remainder 0. So the answer is 16. Now that was kind of complicated. I did a lot of steps, so for sure I'm going to want to check that answer. So let's go back to the original problem. And what if I put in 16 in place of B? So this was the original problem. Okay, 64 divided by something is 14. So if I put in my answer, which I got 16, now I'm going to check, is 64 divided by 16 4? If that's a true answer, then it is checked and it is correct. Now we can get to that smile, and you can smile too because you are done with this lesson. Thanks for paying attention. Bye.